All right, welcome everyone. Thanks for being here. It's our privilege to have Megan Bennett today as our invited speaker. And again, she's a distinguished alumna of the ECE department. And I should mention, I just had the personal privilege of doing my very first HLB induction ceremony with her as the inductee. So it was a great experience for me. It's my pleasure to welcome her here. It's great having her with us here in Arlington. So Megan is an electrical engineer, design engineer at Blue Origin Space Frontier Foundation, and she's a board member as well. She's basically, so let me go ahead and give a quick review of her bio. She's an electrical design engineer at Blue Origin, a company driven to better Earth through space, and a director at the Space Frontier Foundation, a political advocacy nonprofit. Bennett is working on the Lunar Crew Lander for NASA's sister of the Apollo mission, the Artemis, which will send the first woman and the first person of color to the moon. And she grew up in Blacksburg, Virginia, and is a proud alumna of the Virginia Tech Electrical Engineering program. If you've had a chance to look at the abstract, you'll notice this is an extremely interesting talk because although Megan is working on several of the technical aspects of this project, she's going to talk, or her talk is going to also focus on some of the policy aspects that are shaping how we as a community, mankind as a community, see these issues, especially with regard to exploring outer space and doing it in a beneficial way for all of humanity. So I'll go ahead and hand the floor to her without further ado. So let's welcome Megan again. Megan, thank you so much for being with us.
Is it now? We'll see. It's blinking green. So. We'll go to my before slide.
Right, I think we're having some audio issues, so we're just getting that looked at. Please let us know if you're able to hear Megan on Zoom, or I think I saw a few messages saying you can't hear her.
The audio on this is working either.
Oh, do I need to be muted, right? So do I have to join it?
Okay.
Okay, sounds like it's good now. Okay, go ahead.
I don't think the audio is working on this end. I just mentioned that to him.
Okay, I got two messages that are, or three messages that are saying people can hear you. So
they can hear me?
Yeah, just try again. Let's see.
Hello.
All right. Is okay. They can hear you now.
Okay. Cool. I don't think the audio in this end is working now. Yeah. Should be the same as earlier. And then have it all the way up. I didn't touch anything since we tested it earlier.
I think we're good now. It's looking like.
It's definitely a top one. Yeah. It was working. My computer fell asleep maybe. Sure, yeah. I give it a couple seconds.
Okay, stand by, everyone. We're trying the audio at the speaker's end, so. Is it playing? No.
Oh, beans. Okay, that's working now. What'd you do? All right, I'll try again. I think it works now. Yeah. Yep, you're good. Awesome. Woohoo! Thank you, man. I appreciate that.
All right, looks like
Everyone
we're
good on
good to
Zoom
go. Yeah. Is everyone here on Zoom?
Good.
Okay, I think you can start, and if there is an issue, someone will chime in with that.
Cool.
Yeah.
Well, as everything got said, I am still beyond excited to be here talking about unspoken subtleties of building spacecrafts. Once again, my name is Megan Bennett. I work at Blue Origin, a company dedicated to building technology for Earth from space. So, about, in my opinion, what makes the space industry a platform that we can even operate anything out of, and then what these unspoken subtleties are, this ominous title that I crafted for this presentation today. So without further ado, I'm gonna get into the why. So this is just gonna cover my personal background. A lot of people ask me the question, how did you start working at Blue Origin? Like, how did this even come to be? So I'm going to go over a little bit about my upbringing, a little bit about my career at Virginia Tech, and then more importantly, how I transitioned from a seemingly vague and universal degree into a very niche role, working on a very niche program at a very niche company. So yeah, I was born and raised in the Hills Appalachia. I'm actually from Blacksburg, which a lot of Virginia Tech people are familiar with. So grew up in Blacksburg to two loving parents who definitely taught me the value of going outside, making sure to care about whatever it is I'm doing. It was a very, I would say, holistic, outdoor centric childhood. And I definitely enjoyed getting to grow up in such a humble home. And so I definitely call Appalachia home, despite living in the greater Seattle area now. And often think back to this period as something that really made me into who I am today. While I was in high school, I had the unique opportunity to be inquired by my chemistry teacher, who I actually was chicken sitting for. He told me that I should join the robotics team, even though I was just taking his science class. And I knew him because his daughter went to the same elementary school I did. And I was very hesitant. I was like, I don't think this is for me. He's like, well, you should still join. You should bring some girls. Like, we should have more representation in this robotics team. Trust me, take a leap of faith. I was like, great. What has the most 3D printing? Because I thought that was the coolest technology I could think of as a 16-year-old. And he said electrical, which is wrong. That is not the sub team that has the most 3D printing, but it still enabled me to go, okay, this thing is cool. I want to do this cool thing. How do I do it? And I just asked the person I trusted most at the time. And he led me to a direction that arguably had better results, but I fell in love with the process of robotics from a very young age, so much so that when I was 17, so a year later, I got involved with the Terrestrial Robotics Engineering Controls Lab. So this is a photo from October of 2014. Obviously, the Trek Lab is still in today. Dr. Leonessa took time out and still helped me later on. But in this experience, I got to be surrounded for the first time with people that blew my mind. Like, so sincerely, I went into this lab and I would leave with the biggest smile, even though I'm sure every grad student there was banging their head on their code, trying to figure out what was going on and why it wasn't working. But I just had a phenomenal time. And some of these people are still people I look up to more. I'm super proud to have experienced the coursework there. So, like I said, with Dr. Leonessa, he invited me to do a project on the other side of the world. So growing up in Blacksburg and then going to Virginia Tech, it is safe to say I had not been exposed to a whole lot of other subcultures. But when given the opportunity, when Dr. Leonessa brought me into his room and said, let me know when you know where we are in the world. And he was zooming out of one of the islands of Malaysia and Indonesia, Borneo more specifically. I was like, is this the UK? And he's like, oh, why am I asking you to go on this project with me? But he still did. And so I was able to go to the other side of the world, build this structure that you can see in front of you with high-speed cameras that we took in backpacks over the border, which, you know, sorry, Dr. L, if I'm airing dirty laundry by letting everyone know that. But it was a project that was extremely impactful for me personally, because it was the first time I saw how much engineering can have a global effect. The top left corner is me giving a presentation, because in Brunei, they actually have a pretty significant celebration for the 4th of July for whatever Americans are in the country, which I thought was interesting. So being the only American in the country at the time, I was invited to talk on the project. Not everyone else had gotten there yet. And so I made a small scale demo of the technology to explain to the Minister of Education and a US ambassador and diplomat, Matthew J. Matthews. And so this was a good opportunity for me to really see the global impact. Once again, we were studying jungle bats, which I don't have a picture of today, but it really was such a good showcase of saying, okay, I have this interest in engineering. I don't really know how to apply it, but hey, if I get to go to the other side of the world and the EC department values that and they'll sponsor me, that's awesome. So I got to spend several weeks in Brunei, Southeast Asia, Singapore, learning about the material selection process, learning about the build process there. And although that was really cool, there's still some itch and I couldn't figure it out. But as I was an undergrad, I was exposed to whitewater, I was exposed to rock climbing, I was exposed to projects like this, but there's still some itch. I couldn't really explain it, so I'll just show you.
We go for main engine start. We have main engine start and the ignition and liftoff. Liftoff of STS-7 and America's first woman astronaut. And the shuttle has cleared the tower.
Hello, Doctor. Mission control confirms roll maneuver starting. Now time on all that count. 20 seconds. Rush looks good. 25 seconds. Roll maneuver completed. 30 seconds. Challenger now 1 nautical mile down 75% program.
So this is Sally Ride, the first American woman in space. Now, I chose this moment because, one, it's a great moment in history to reflect on when you think, why is space so cool? And it's because the government decided to prioritize missions like that were extremely successful in carrying out their mission. And so Challenger, which later exploded, as I hope you all know and have studied extensively for the engineering ethics perspective, is a great example of how we can do hard things, do them well, and do them consistently. And now there are many more women who have gone to space and done experience. And this is just one example that was kind of that itch in the back of my head as I was navigating my undergrad career that I didn't talk about a lot at the time, but really felt this like core sense like, oh man, that's really cool. Like that'd be so neat to work on that one day, but I couldn't quite figure out how to do that, especially because, I don't know, it just seemed so unattainable at the time. And so I did what anyone would do, and I worked on experimental aviation. This was the next closest thing I could get my hands on. I'm sure that the space companies I applied to loved my attempts, but didn't love my GPA as much as they loved my passion. So I decided to throw myself at a project that would undoubtedly put me in a circumstance where I would be working hard and I would be working efficiently. So in 2021, Vanilla Unmanned smashed the world record, and this is held and recognized internationally, for a long endurance class 3 UAS. So this has a payload that is very significant for its class and a wingspan of like 30 feet or something like that. And as you can tell, it launches off of a truck bed. So this is a UAS system built in Maryland. And once you get to about 60 knots or 60 miles per hour, the vehicle autonomously takes off from the loading platform. This is very significant because you can launch it pretty much anywhere as long as you have a short runway length. And more importantly, it flies for 8 days, 50 minutes, and 47 seconds without having to refuel, without solar. It is the most efficient lawnmower engine that has ever been handcrafted by a bunch of technicians and mechanics that are way smarter than I am. And so this was a great opportunity for me to see and build, quite literally in a lot of cases. Like I did a lot of soldering, I did a lot of harness building, and exposed to a lot of different techniques that had these very extensive standards. And especially with naval aviation, it is extremely important that you adhere to those standards to a T. And I'll talk about this in a second, but the difference between a lot of spacecraft and a lot of aircraft is these things go through the ringer. Like, it is not a gentle process to take an aircraft, launch it into the sky, and then have it shake for 8 days straight and nothing to break. And so I got a very good exposure as to, wow, what can this cable do? What can this PCB go through continuously? And we were on a very strict schedule where, like, we were flying for 2 weeks at a time every month or two. And so if you're interested, the platform is located right across the river. But more importantly, I think that it was the first time that I got my hands on a project like this. And I got to see cool applications. So this is a picture that is public of Vanilla flying over the Arctic Circle for a NASA project to measure different ice and snow depths. And you can tell the difference based on the instrumentation. So this is a great example of a research project getting thrown on a vehicle that can achieve a mission like this. But this is an aircraft that I got to work on with one other electrical engineer. So I could safely say that I got to do some stuff on it. And that aircraft has my handprints somewhere on it. But it was still doing this really interesting project. And I got to see where the funding met the technical backing. So for me, if you know me, that bar still wasn't high enough. And I still had that itch that, like, ooh, that'd be so cool if I got to do space stuff. And so I did what any sane person would do and said yes when a good friend of mine reached out to do some electrical contracting, which resulted in this.
5, 4, 3, 2, 1, ignition. And liftoff Falcon 9. Go SpaceX, go transporter 10. Doubling MOD team pressures.
And somehow this still does not look real. It is the same audio clip, I swear. Like, honestly, doing a side by side as I was making this presentation is like, can you even hear the difference in the first couple seconds? It's that same countdown, that same rumble in your chest. It is undeniable the effect that it has on those watching the launch, those having projects in the launch. And this was especially impactful launch because I think there was like over 30 payloads, if I'm not mistaken, that were from commercial space companies and payloads that intended to fulfill projects. And so mine is in the bottom right corner, the OWL project. I was contracted to design, build, and test the cabling system for an optical payload, a small payload that goes on satellite that was built in LA. But it was the first time I really got to take full ownership. Like, I was the only person doing this. So they said, okay, build me this cable. And I was like, oh, shoot, wait a minute. This is going to space and no one's going to touch it. I can't build it the same way I build a naval aviation standard. Like, huh. And then I reached out to a bunch of friends that knew way more than I did and were able to say, oh, remember when I built that shuttle mission? Like, use this document. It's like, oh, I will do that. And so I learned a lot about materials. I learned a lot about build techniques. And I learned even more about what it means to define, build, and fly in a very condensed period. So this happened from June to October, and it all happened in a very condensed amount of time too. They flew in New York to build everything, and then lo and behold, it launched only a couple months ago. So this was, I believe, the second day of March or so. And so it was not very long ago that I was able to say that something that I have put my hands on is now orbiting space, which is pretty incredible. It was a milestone that I wanted to be there in person for so bad, but it's okay because what matters is it got it there and it's doing what it was designed to do, which is something that I come up this even get introduced, I will talk more about later. But more importantly, this opportunity and being able to say yes when I was presented to it and build the skills. So just at my last, enabled me to land a job at the company no other than Blue Origin.
I was strolling on the moon one day in the very month of December. May, when much to my surprise, a pair of bunny eyes. This is a neat way to travel, isn't it, Frank?
So I cannot help but smile literally every time I watch this video because it's from Apollo 17. And that was one of the later Apollo missions. As you guys know, Apollo 11 was the big, like, you know, one giant step for mankind, one small step for man. Woo! But Apollo 17 was one of the first times we were comfortable enough with the Apollo missions to not only get to the moon, but play around. Like, this is an exceptional example, in my opinion. Like, hey, we're doing something so proficiently. We are humming on the moon as if we're going through a stroll through a field of daffodils on Earth. And it's like, wait, hold on a second. Like, what's going on here? So at Blue Origin, the project that I'm working on now is called Blue Moon, which is an encompassing term for the Artemis mission, where not only are we going to send Lunar Lander 1, Lunar Lander 2, hopefully 3, 4, the business unit is called Lunar Permanence. That's in small text at the top. But Lunar Permanence's goal is to not just say, hey, we got some money from the government, let's go send something to the moon. It's saying we want to create a structure in which we can do this, do it consistently, and before we know it, as we're building this generational impact, once we get this down, we get it down well, we keep doing it. Then we can start thinking about mining resources. Then we can start thinking about other types of applications, like building fiber optic cables in a low gravity environment is extremely important for seeding those structures. So if you're able to say, like, hey, this is a very invasive process to do with restrictions like gravity, which is obnoxious consistently, like, annoying of Earth to have these limitations. But if we can get to a point where we can find those things on the moon that enable us to build technology more efficiently, and then get this, take advantage of the lack of gravity once again, it takes less energy to launch off of the lunar surface than it does off of the Earth's surface. So once we do get to a point in manufacturing which we are able to harness these resources and able to manufacturing them, it doesn't take much to get them into Earth. And then you have these projects that are able to say, hey, I want those resources so I can refurbish this satellite. Hey, I want those resources so I can build this other component. And then you're building an entire manufacturing infrastructure in space that then you can bring back to Earth. And that's a significant bit. Everything in Blue Origin revolves around the idea of building space for Earth. So although it seems abstract, the idea is that you do things so gracefully, which is why the logo is a feather falling and a symbol's flight. You do it so gracefully that once you do it so consistently that you can hum on the moon and you can build an infrastructure that actually revolves around an interplanetary ecosystem, which is just wild to say that we are so close and my generation's doing that. To talk a little bit more about Artemis and Blue Moon, I will briefly mention something that I really love, and that is Mark II can carry 4 crew. And so not only is this just a habitat that will land on the lunar surface, this is something that will need to land, launch again, and do that 5 times with different astronauts each time. So it'll rendezvous in lunar orbit, it will have to land again, it will have to launch back out, and we are going to send several unique missions, ideally just the start of something completely new and advantageous. So very important. And I can mention that it's liquid hydrogen oxygen, which is part of the reason why we are hosting it in the lunar orbit for, staging while we're waiting between crews of astronauts. But this is the first time since the Apollo missions that we've done something even close to this. Intuitive Machines launched not too long ago is the first step of doing this. And it is so significant that this isn't just like, oh, it'd be cool if we did this. It's like, no, we are doing this. Like, this will fly. And I feel that pressure every day. But I'm very glad I can share that insight for you guys. So although I grew up in Appalachia and had an exceptional opportunity to get my education at Virginia Tech, this is my backyard now. Same mountains, but bigger and more daunting, but also so much more exciting. This is Mount Rainier. So looking at it incites just a sense of challenge in me that gets a little giddy, right? And so this is a great example. Making something familiar and then be like, what happens if I trust and lay the groundwork that I exemplify that and then see what happens? And for me, that's landing in Pacific Northwest and seeing what's out there. So how did this happen? You know, Blue Moon is cool. Blue Origin's awesome. SpaceX is great. There's a lot of incredible companies that are doing incredible things. But I don't know if you guys know this. Before 2004, this strides that have been made, especially in the governmental side, that have enabled this platform to even exist. Why I'm even talking in front of you today is because of policy. So this is an example of kind of like the ends, and then I'll get to the means in a moment. But this is the summary of commercial spaceflight specifically for humans. So the bottom is Blue Origin, the top is Virgin Galactic and their little space plane, if you guys are familiar with it, and then the top left is SpaceX, which is one of the more notorious ones, doing the Inspiration 4 launch. And so I wasn't sure I was going to mention this, but I guess I'll just say it. I personally know an astronaut in every one of these photos. So I know Sharisha, I know Audrey, and I know Dr. Cyan Proctor, all of which have been incredible mentors in my life. And so I am incredibly grateful to be a part of the space industry. Know astronauts who have been first in making this road to space. And more importantly, I get to be a part of a process that this is normal. Like a lot of you probably don't know, I don't know the last time humans were spent in space, because now it's becoming normal, which is insane to say. It's insane to think about. And the fact that this isn't just like a plane, she's no kidding, just doing flips outside of Earth's atmosphere. Like that's so cool. So yeah, I definitely want to incorporate this slide. And also Dr. Proctor, who's the first African-American woman pilot to pilot a mission like this, is an exceptional person. You should do all this and learn all these things. You have a quick question? Huh? Oh, I would not hesitate. If the question was, do I plan to do this? Yeah, absolutely. Like that'd be so cool. Are you joking? Wouldn't you as well? But yeah, Blue Origin especially does an exceptional job picking out people who have missions that can be further emphasized by having what they call the overview effect, which is the experience that a lot of astronauts describe when they go to space and go, oh, wow, that's a thin atmosphere. Okay, yeah, maybe we should take care of this fragile blue marble, hence the name Blue Origin, in case you're wondering. But, ooh, maybe we should think more about, pollution. Maybe we should think more about environmental problems like, let's get as many people in space as possible so they feel like this too and then become ambassadors of the overview effect and go into this industry with a little bit more insight. So yeah, getting into the nuts and bolts a little bit, and this is where I'll spend a bulk of my deep dive of the presentation. So like I mentioned, before 2004, this was not an option. This wasn't even close to an option. So within the space industry, policy has never not existed. It has existed as military, it has existed as exploration through NASA, but more importantly, and especially the Challenger mission, which we saw a couple slides ago, right? The vehicle that brought Sally Ride to space tragically exploded preventably. And that is something that I do not take lightly. And so all of these people who were rooting for the space program in the United States, who were heartbroken, thought, okay, what are we going to do about this? Like, we can't see all this momentum die with this mission. Like, that's not fair to the people who were on that flight. That's not fair for the people who had that implied risk. And it certainly is not fair for all the future astronauts, one of which I also am getting to know really well, who was supposed to be on the next Challenger flight and now is broken the sound barrier a couple times. He's a very cool person to like learn about how lawnmowers work from as well. But the point is, the Commercial Space Launch Amendments Act of 2004 fundamentally changed how the government can exchange resources. And this is significant because it went from NASA being this all-encompassing power that says, hey, I own the spacecraft, I regulate the spacecraft, I own research, I own the launch pad, I own everything, to the FAA monitoring the space industry the same way that we monitor commercial aircraft. And that's loose, but you get the idea that the FAA is now the overarching regulator of commercial launch vehicles. And so, because of that, we can now categorize space companies domestically and internationally to launch, payload, and service providing. Service providing has a lot to do with networking, which is something that I didn't realize we were doing so much of here. And payload companies are anything scientific that like is how to grow food better, Fun fact, humans have been trying to figure out how to do that more efficiently, literally since humans existed. Efficient with building technologies that can enable projects like engineering foundations to be more efficient. So payload companies, service providers, and then launch companies. I don't even know how many launch companies there are now, but I know there are a lot. And Blue Origin happens to supply a lot of engines for them. But the point is that this exists because of the Commercial Space Launch Amendments Act of 2004. And Jim Muncie is a huge reason why. There is one person who was sitting in Alexandria, no less, and was like, I can do something about this. And he wrote this, like 80% of it. So where did Jim Muncie get this inspiration from? The answer is sci-fi. Like, who is surprised? It should be no one. So the role of sci-fi, in my opinion, through all of technology, not just the space industry, is absolutely critical. Like, you cannot have the technologies we have today without someone using their imagination and thinking about it first. So here's the thing. I'll put my mouse over so you get this. These are my two favorite robots in the cinematic universe, R2-D2, C-3PO, and then I had to get my grandma, who's the biggest Trekkie I know and own, through the Enterprise because I love her so much. But I want you guys to take a second. So when you see this, do you think of a small human in R2-D2? Do you think of a larger human in C-3PO? Do you think that this is a soap bottle? I actually met the person who made this prop, and he was telling me that he got the inspiration from showering. Like, he took his shampoo bottle and carved it. And that's how he made the prop for the early Star Trek episode. We made this out of shampoo bottles before they even had the opportunity to know what a microcontroller could do for us in a classroom environment, right? And so what I want to emphasize, especially to this room of electrical and computer engineers, is when we look at this, we don't see a shampoo bottle and people that are dressed up like robots. Like, I know when I watch sci-fi and Star Wars and all these videos and all this media, I think to myself, like, how would I program that? Like, how would I build the electrical infrastructure to do this? And I think that is an extremely critical link that a lot of people don't realize they have that power of. And so when you think about this sci-fi world that we live in, where, like I said, we're sending people to space like it's nothing. Like, I don't even know when the last launch was. Like, that blows my mind. But it stemmed from someone letting their imagination go rampant and then making a movie about space cowboys and spaghetti western we call Star Wars. And so with that context, I want to emphasize something, that not everyone thinks like this. Not everyone sees the electrical engineering or the computer engineering side or the computer science elements of these projects when they look at just an image. And that's really significant to take home. So something that I noticed through a project that didn't go great, but introduced me to our government at a very, very intimate scale, is organized momentum. And that is something that I really want to talk a lot about today. So as a Civics 101, how the United States is governed, we have the Constitution, we have the legislative branch, we have the executive branch, we have the judicial branch. Within those branches are people. You know, like, my partner personally flew the president around, or actually the last two presidents around, but that doesn't matter. The point is, like, these are people. And Congress, House Representatives, Senate, these are people that represent you. Whatever state you're in, their job is to represent the person living in that state. And so it's incredibly important to have workshops to figure out, like, okay, what is the idea that we have? To have training to be like, okay, how do we talk to these people? Like, how do we talk about sci-fi but not make it weird, and have policy that backs it, like the Commercial Space Amendments Act of 2004? Like, how do we schedule meetings and have notes and significant follow-ups? Like, how do we have that impact? And so for me, the answer to this is prioritization. And I'm sure this is something that has come across a lot of people's feeds. It's why I have the impression that I've done a lot of things, but really, I just feel like I got lucky and did one thing, did it well enough to keep progressing. And now I have not taken that opportunity for granted, excuse me. And so something that the Alliance for Space Development, and also just the Space Frontier Foundation, the organization I sit on the board of directors for, does extremely well, is setting the tone. They set primary objectives and they set secondary objectives. Now, this is especially significant because if we look at the way the government is structured, of all the people sitting in Congress, I hate to break it to you, but not all of them care about space. And that's okay. If you have a Congress member that has a a like lawyer background, you want them to care about criminal justice. If you have an electrical engineer who went to Virginia Tech senator, which is someone who sits in Congress, like a Hokie alumni, that's pretty cool. He cares a lot about science and space technologies. And that's why even within the House of Representatives and Senate, you have committees that are dedicated to solving problems effectively. It's not the role of every congressional member to care about everything. It's the role to listen to the people they know care a lot about certain subjects and then influence the vote accordingly. And so with these primary and secondary objectives, if you go into an office and they say, oh yeah, like I talk about space, you go, great, let's talk about everything. If they go, honestly, I think the lunar landing was fake, then you respectfully take some M&Ms and then you move on. And that's okay too. But the practice of going through this, figuring out what your primary objectives, figuring out your secondary objectives, is what makes impactful work. And so that sci-fi lens that we all carry, the fact that we can look at R2-D2 and C-3PO and go, oh, I wonder how I would make that, is how you can have meetings that have long lists like extending the learn period and preserve information consent. And then make that applicable. Go into these congressional offices, find champions of these legislation, and then literally build the foundation for the projects you care about to have substance. And in so many cases in policy, and why I think this is so important, it's not because you go in there and say, hey, my name is Megan Bennett. I would like $400 million for this NASA project because I want to work on this NASA project. They will, instead of you leaving with M&Ms, they will just escort you out and say, oh, I'm so sorry, I have a meeting, and then shut the door and lock it. But before we get to that point, that's why the brainstorming, that's why the authoring is so important, because if you're able to change a couple words in the law, like the way Jim Muncie authored his document, then that's great. You've already won, because instead of asking for money, you're asking for legislation and the foundation of which these programs are built to support your future endeavors. And that's really something you're like saying, hey, can you throw development at the end of this? Or, hey, would you mind extending the learning period so we can figure out what regulations look like before you put them on us? That'd be great. That's how you go from saying, okay, like, how do I do this thing, to making the platform to be able to do that thing that you want to do. This is a great example. It actually circles back to the first slide about these astronauts, right, that are commercially going to space, because the extension of the learning period is dependent on these space companies coming to a consensus. Competition is great, but it doesn't matter unless you get to a universal decision that says, this is the best way to design a rocket to do this. And the FAA was saying, hey, we gave you 8 years. I don't care that you were COVID. I want you to start regulating rockets now. This ask that I personally have gone to Capitol Hill and met with congressional members to talk about is saying, no, please don't. Like, we're not there yet. Please extend the learning period. Like, that'd be great. We don't have standardization yet. If you put standards on it, it will hinder this progress that we've worked so hard to make, and the policy that we have authored and the doctrine and then seen turn into law, like in 2004, which kickstarted this whole thing. And then talk about that in a way that's meaningful with whoever it is that you're talking to. And so this gets me to the final point of the how, which is the importance of outreach and advocacy. This is Jim Muncie talking on C-SPAN back in the day when it's so wild to have this all recorded. There's Eric, who spoke with us yesterday. I did not even realize that before I made this slide. And there's me on Capitol Hill and the Alliance for Space Development and our backyard right now. Do you guys know that this is one train stop away? Because I do. Like, and these are all buildings that are made for the people. Like, each one of you and everyone online, hello, has the ability to say, okay, this is something I care about. I don't have a platform for it. How do I make a platform for that? And even if you don't know, find someone who might. That's a great start. And if you don't find someone who might, then workshop and find people until you figure out how that looks like. So what is the point of this presentation? Like, what are these unspoken subtleties? I've talked a lot about policy. I've talked a little bit about my personal background, which I think is significant. A lot of people ask me to introduce myself, even though I was hesitant to do so, because I'm much more interested in hearing what you guys have to say after this and the research you're doing, which is why I was so happy to get all those tours earlier. Like, in this building alone, which is the Virginia Tech Research Center, there's some incredible stuff going on that in my opinion, will impact the world even more than some of the lunar lander objectives. But I digress. So this is a quote from a book by Dr. Catherine D. Sullivan, an astronaut and also a Hubble engineer who worked on the efficiency of Hubble. And she says, the only thing we truly do alone is have the start of a good idea. And I think this is so significant because until I read it and then had to go, and then I shut my book and thought about it for 30 minutes, this is true of any environment. Like, there is no example of someone coming out of the womb and then immediately getting to where I am today. Like, there has to be inspiration, guidance, mentorship, learning. Turns out we are all able to sit in this room today and hold the knowledge we do in the fields of electrical and computer engineering because someone figured out what imaginary numbers were 1,000 years ago. It's not because we all were like these geniuses who woke up one day and are like, I'm pretty proficient when it comes to circuit analysis. Like, no, it came from someone having the start of an idea and then someone making Virginia Tech, who knows how long ago. I should know that number, but I don't know. I'm graduating. I'm an alumni. It's too much. But the point is that having the start of a good idea is the only thing that we can do by ourselves. Everything beyond that, we need to figure out how to do together, which is why I think one of the most important things you can do in the free time is networking. Whoa! So I like to think that this is a skill set that can be built. I hate the term soft skills, which I'll get into in a second. But networking is an example of how you can take something that is seemingly unconnected and connect it to everything. That's why I'm so passionate about working on the space stuff, because it's very obvious. Like, space draws people in. Like, oh, that is cool. Like, you felt that rumble earlier. Like, you can't not be like, all right, that's pretty neat. Like, even if you aren't completely related to that project or don't care about space, that's fine. I won't judge you too much. But networking is the ability to take these ideas we have, those inclinations, our gut feelings, and then work on them further. So as defined by Columbia, networking, why should you do it? Networking is the process of making connections and building relationships, which is true. All this is completely accurate. But from my experience, and some people that know me well would say that I, treat networking a little differently than Columbia suggests for their career education department. And from my experience, I've come up with some fundamentals that I personally think change the way I view networking and could hopefully change the way you guys view networking as well. So 1, understand your mission statement. Hopefully by now you've gathered that I care a lot about building an environment that leaves the Earth even marginally better than we found it. Even though I exist and I fart and I do all these things that will leave a negative impact, I ultimately want to make sure that I understand my mission statement and then I prioritize those efforts. 2, be curious, ask questions. But when you ask those questions, listen hard to those answers. Sometimes, even if someone doesn't know the answer, but they're trying to explain to you, like professors are an exceptional resource when it comes to this list. Like, if you ask a question, and even the professor doesn't know in depth the answer, there are a lot of instances where the process of answering questions will give you answers that you did not realize were there to start with. And so 3, become an expert. If you listen hard to those questions, chances are you'll become an expert in something, even if it's an internal question, even if it's an external question that you're having conversations about, become an expert and then apply your skills. Research projects are a great example of this because you can take this skill you have and say, yeah, this is a skill, this can do something, and then you go apply it. And then you'll spend years of your life doing that, and hopefully it works at the end of it, right? But once you figure out these skills, learn they're valuable, champion your ideas. That's what the dissertation is for. That's what me coming out to talk is for. Championing of ideas and lifting those around you up. You cannot do this alone. And I cannot emphasize this enough. Like, when I was 17, going from building a robot in a high school in Christiansburg to being surrounded by MIT grads who were building humanoids, like, I would not even gotten the opportunity if it wasn't for that one teacher to say, hey, come here. Like, let's expose you to something, and me reluctantly saying yes. So 5, we understand that it's important to prioritize, ask questions, all that good stuff. But above all, life is short. Be aware of limited resources. Time is the most valuable resource we have, in my opinion. And if you are conscious of others' time, when you go to ask those questions, when you're meeting with congressional members or just when you're meeting with peers, be aware of their time. Like, go up to them. Be concise with how you ask questions And once again, pay attention to the answers they give you when they ask questions, because their time and their mission is not necessarily less important than yours. Like, no one on this earth is coming across this like, yes, I am more important than this, and this is more important than that. It's no, prioritizing your efforts does not mean that there's a hierarchy of efforts that has now been established. It just means that you need to be cognizant that your time on earth is limited, and you need to figure out how to make the best of that. You need to start doing that now. And so as you're figuring out what your mission statement is, how these weaknesses can be answered, learn them. Learn your weaknesses. Number 6, seek help when understanding novel ideas. This is incredibly important. This is why you have advisors, and this is why I have a network of mentors that I have cold emailed or messaged or had dinners with or coffees with, that I've just taken every moment of advice they've given me and held it close to heart. So yeah, enjoy the process. Love what you do and those around you. It doesn't hurt to bring in cookies occasionally. It really doesn't. It doesn't hurt to get to know the people around you as you're seeking your professional programs. It really doesn't. Get your job done first. That's something that I've learned more than once. But enjoy the process, because that will make the work even more impactful. If you can leave the end of a PhD or graduate program and be like, oh, that felt pretty good. Like, that's a testament alone. So yeah, build your skills, even if your problem are not defined. Even if you don't know what your mission statement is, build those skills in the meantime and keep exposing yourself to inspiration. So in my opinion, like I mentioned this earlier, like, I do not like branding soft skills. I think that's silly. I do think it's a skill to, like, that's why we teach young humans to say thank you and please. Like, I absolutely think it's a skill to email people and to follow up on emails and not be afraid to draft a pitch, a business pitch or a sales pitch, whatever it may be, or just an ask saying, hey, I see you at Columbia, you're doing something similar to me. How did you do that? Like, I love the idea of making emailing a skill. I know it doesn't seem like it, but say thank you, email people, learn circuit analysis, learn technical writing, learn how to write grants, learn how to solder, learn empathy, learn math, learn robotics. These are all skills, and Virginia Tech has, in my opinion, done an exceptional job prioritizing those skills that are built into these major programs. And so that's probably why, the ECE advisors chose me to speak on this so long ago, but I still think it's incredibly important to have this technical backing. So what's up with the balloons? Like, I know that I put these out here and it's kind of ambiguous, but definitely on character for me. I'm a big fan of props. I built this slide in because one, I got it, wanted to pace myself a little bit, but more importantly, if anyone knows me, they will hear the term, my friends are my heroes. And I mean this so holistically. Like, when I establish my network, I don't say like, who can help me the most today? Often it's the other way around. Like, hey, how can I help you? And when that happens, you build meaningful relationships. And by accident, I got to have dinner with Bill Nye at the Swiss ambassador's house. Like, that's pretty freaking cool. And I got to meet all these people, and I have friends that have taken me skydiving because they felt like it and have a plane. And some of my really good friends and people I admire, like Dr. Wood, who is doing just the most exceptional research in the space-enabled lab, where she is taking beeswax, turning it into satellite fuel. She's taking novel ideas and making them into reality. Like, instead of just saying like, oh, it'd be really cool if we didn't colonize another planet, she's like, no, let's define what anti-colonialism is so we don't repeat the historic fuck-ups of humanity, right? And so it's taking this example of like, okay, who's really cool? I want to get to know them more. My friends are absolutely my heroes. They don't take no for the answers in the right circumstances, and they are so open to understanding the opportunities that present themselves, like me talking to friends today. So the bottom is like me nerding out a little bit. I wanted to emphasize some importance and just say like, okay, how did this even happen? Because someone asked me, I'd like to come up with an answer, and quantifying things makes me comfortable. And so the top one is how I was introduced to the space industry. I was introduced like 10 years ago. It was 2016. I went to my first conference. I was like, I didn't know I could actually do that. And then in 2017, I went to another one. In 2018, I went to another one. And then 2019, it happened more. And then I kept introducing myself and exposing myself and going, wow, this is really cool. And it is still cool. And it keeps being cool. And then I just kept exposing myself. And I think that's really important. And then Second bullet, because it's hard. This is me just like literally applying, where it's like, even though I was exposed to the industry, I had this deep imposter syndrome that I was like, there's no way I could do this. Like, there's literally no way, even though I'm standing in front of you telling you that this is what I do. And I didn't start applying to jobs until the end of 2020. I was exposed 5 years prior. I had a curriculum of people saying, you could do this. And I didn't apply jobs till 5 years later because I was like, it's still not for me. I'll take a co-op in DSP because it's comfortable. Thank you, though. And then consistently throughout my life, and a lot of people make fun of me for this because I have my like quarter life crisis or third life crisis or whatever often, but I'll challenge my ideas very periodically. So even though I didn't say like, I want to do the space stuff, I challenge my ideas a lot. And more importantly, I was building those skills the whole time. Like, even though I didn't know what to do, I didn't know how I apply it, I was building skills. And I think that's very significant. And so what's with the balloons? Like, honestly, I wasn't sure I was going to do this, but I think it'd still be fun. This is an example of like all these things that I wasn't sure, like, why did I blow these balloons up? Why was I collecting these skills? Why was I doing this? And the answer is like, whether it's building relationships while it's learning circuits, like it's saying thank you. Like, it truly only takes one to make an impact, right? I know it's cheesy, thank you. But the point is that it only takes one balloon to go, oh gosh, like, why'd you do this? And I startled easily, so I don't know why I did that to myself either. But the point is, like, I didn't know when I was blowing these up which one I would pop. I have no idea, like, which one will pop later. Like, I don't know. I cannot tell you which opportunity will come up next. If it's continuing to work on Blue Origin, which is sincerely what I hope to do, I want to see this thing launch and land more than anything, right? Like, that'd be so cool. But I also want to make meaningful connections in the meantime. Like, that's what life's about, in my opinion. And so, with that being said, I think something that I want to bring home is that there's progression within the process, right? So I was open to opportunities. I volunteered. I thought, how can I help more? Like, how can I do this better? Like, looking at those around me who are experts, be like, hey, like, I see you're exposing me to how to build these robots. Like, how do I do that better? How do I make myself more efficient? And once I asked that question enough, I was like, okay, I've got this thing called confidence now. Like, I went from being able to say, like, how can I help, to getting a rough idea of it. And then I started running my own projects. And then I started getting recognized for those actions, which is what brought me into the leadership positions that I am today. And once I was recognized and got into those leadership opportunities, I looked to those around me for further inspiration. Like, in my opinion, this is the peak for me, right? I am doing my dream job. I am doing meaningful work in my free time. And now I just get to look around and be like, isn't this awesome? And so that limit does exist, and I cannot tell you it did, even a couple of years ago, as you saw by my own like little personal time. And so how can you do this? Obviously, you should be dedicated to your craft, but I also think that giving back is an exceptional way to do that. Like, be grateful for the resources you have. Like, it is exceptional that we don't have to think about food all the time. Like, maybe we do sometimes if that bank account's getting a little bit low. I mean, I went through undergrad, right? But give back to the community. I spend my weekends judging for first robotics competitions, which is full circle, because that is the same thing that got me into the space industry and into this journey. Like, it took one teacher saying, hey, I want you to do this. And I gave it a try. And now I get to share my expertise and the skills I've gained and impart that into students in a judging role. And so if you don't know where to start, look around, go help with the planting, go bring in cookies, go ask someone if they need help walking dogs. Like, it really is, like, I don't want to oversimplify it, but sometimes it is that simple. And there's a reason why the billionaires of the earth just have these eccentric experiences now, because it's like, what's left? Like, that limit absolutely exists. And usually the answer lies in community. So as you're giving back, as you're thinking about all these things and all these cool projects you want to be a part of, think about how to apply your research, right? And so personally, I always go back to the Sustainable Development Goals from the United Nations. There are 17 of them for 2024. They vary anywhere from, no poverty to, clean rainwater, like all these very holistic and broad problems. But if there's a way for you to apply your research to any of these goals, I implore you that you do that. I think it will help you feel better. Once again, I think the goal is everyone walks across that stage going, you know what, that did feel all right. Like, I don't mind that I spent this amount of time, my most precious resource, doing this, because you can make an impact, but you can't do it alone. So remember, you are the only person who can carve your path. I have no idea what all of you in this room do. I'd love to get to know that further. But the point is, like, you are the only person who can carve your own path. You're the only person who has the exact set of skills and the exact life experiences you have had. It is up to you to figure out what to do with them. So thank you. That's it. I guess I know we started late, but if I just hit 50 minutes, so if there's questions, I'll still hang out.
No, we're totally fine with that. So wonderful, wonderful talk. I think it's something that all of us can kind of personally relate to, regardless of what we're doing, what stage of our lives we're in. So thank you so much, Megan.
Yeah, thank you for having me.
And I think we have time for some questions now. So if you're here, please, make sure to use the mic. Or if you're online, you can type in the question or just speak. And we'll.
Hey, Megan. I had a question about, you had mentioned the payload that you had a project on, and I something about like Ondasat Owl. What was actually the purpose of that project? I don't know if you mentioned that. I didn't hear it.
Great question. So the question was, what is the purpose of the Owl project? So that is actually several facets. So there's star tracking, it's observation. The primary goal, kind of like the aircraft I worked on, is to look at other spacecraft from space. So if you look at the Scout, I'll give them a shout out, the Scout website more. They have a much more in-depth look at that. But the primary goal is to have a camera system that can star track and do like some navigation and guidance, but also look at other spacecraft from space. So it's kind of like a surveillance application of spacecraft.
Cool. Thank you.
Yep.
So Megan, thank you for the very inspirational speech, and I'm sure a lot of us really can benefit a lot from how you actually conduct your life and career trajectory. So that's wonderful. One thing specific I wanted to ask is sort of a higher level on the technical side. Early on, you mentioned that the Blue Origin is really the mission, if I'm not mistaken, is really build those spacecraft for the Earth. What about actually build the spacecraft just for the human to explore as far as we can, as deep in the space as we can? So what's your thought and the feeling about that? And by the way, also, how do you actually think, if you think along that direction, how would that actually impact your life and the career trajectory thinking?
It's a great question. So to summarize a little bit is, what do you think the importance of just exploring to explore is, instead of just having this secondary mission? Well, I think the answer is, the walking on the moon video of Apollo 17. It's also the fact that we even looked at the stars and thought we might be able to get there. So I personally love looking at historical examples of Voyager. That's one of my favorite spacecraft. I love looking at examples of Hubble, James Webb, where you see these examples of like, I don't know what's going to happen, but I really hope it works. And then from there, like, the only agenda once the technology gets there is exploration. And so in my opinion, I think it's absolutely important. Like, I think that it is very, very critical to have an application that benefits humanity. However, once we get there, like, we should go on a walk. Like, we should have a good time. And I think that's an important element. And there has never been space exploration without that element.
Yeah.
Megan, great talk. I had a lot of questions I wanted to ask you, but what I've come down to at the end is, can you talk a little bit about the role of your parents and your family in kind of shaping this wonderful exploration and how you evolved?
Sure. Yeah, once again, I was raised by some very earth-centric parents. They were hippies, for lack of a better term. I grew up going to music festivals that they founded. If you've ever been to Floyd Fest, I've been to a vast majority of them. And so I think something that was insistent is, having a deep understanding of the world around you and having a great appreciation for the earth. Like, one of the only activities I had as a kid was walking around, like looking at bugs or collecting leaves or going to camps. Like, I was a reoccurring attendee of every STEM camp that Virginia Tech had to offer. Like, I am a product of the SEED education program, without a doubt. And I do think that's a really critical time to have that inference and show off these cool projects. So I think my parents did a really good job throwing me into these camps and STEM workshops and learning very quickly that I was more inclined to do math and science than sports at a high level. And so they heard that judgment free, and they're like, okay, yep, let's do more of that. And then they put trust into those around me to take it from there. Oh, thank you. Yeah, that's a good question. So just to recap, your question is, what is the biggest hang up technically for the advancement of these projects? Yes. So that actually varies a lot project to project. I don't think I can personally give an answer to speak on behalf of the whole industry, but I can definitely say that the influence of the generation of the projects, once again, getting back to the policy and the wording of a lot of projects, often has a lot of impact on that. Like Blue Origin is a very mechanical rooted program. Same with Platform Aerospace and the experimental aviation I worked on. They're all rooted in a deeply mechanical core. And so for me, and I'm experiencing this now because I get to work under a bunch of NASA JPL vets who are very, very passionate about what they do and have extremely high standards, which I am still working my ass off to try to meet. I think something that's important is to realize like a little bit of that history element, like what influenced the creation of these projects, and then how is that influencing problems we have now? Because you can predict a lot of them. Like if it's a mechanical focused group, they're going to solve mechanical problems first and prioritize mechanical problems. So chances are the electrical, computer engineering, and networking, in some cases, are not even thought of at all, if not just afterthoughts. And that's not a disclaimer to anyone. There are so many great minds, but no one's perfect. So as these projects are generated, you can look back and see where the hangups often have to do with the curator of those programs. So I don't think that there is a perfect answer to that. And obviously, like, materials and resources are great to have an abundance of, so that could be seen as a problem. Obviously, we experience that a lot in the semiconductor world, like having limited resources. But more importantly, I think that at this stage, it's about figuring out how to reliably build this technology before we figure out what limits is resources have, since we haven't hit that point yet, in my opinion.
Other questions? Anyone on Zoom? Unmute and ask. So I actually had a question, kind of following from what Maddie just asked. In terms of policy, so you mentioned that the FAA has oversight over policy issues and anything that's policy related, right?
FAA has regulation over spacecraft.
Okay.
Yeah.
Is there in your, I know you've only been there a short time, so it's actually pretty phenomenal. You've achieved so much, but have you, in your experience, has there ever been a time when what the FAA mandates sort of conflicts with your personal goals or your company's objectives?
Yeah, absolutely. So I think that there are a lot of instances where, in an effort to make space travel and space commerce as safe as possible, there are a lot of examples, in my opinion, of regulations being put on prematurely. And so something we talk about a lot in the workshops we have with what prioritization we have on different policies and legislation we want to alter is the idea of implicit consent. And so we would like to get to a point where people going to space is the same equivalent of going whitewater rafting, right? Where you know that that's a scary thing to do, and you know when you get in that raft that you are subject to the river's will. Right. And so right now the FAA, and rightfully so, is putting a lot of restrictions, especially when it comes to space debris. Like, the government is responsible for the part of the ISS that fell on that person's house in Florida. And so it is really critical that those restrictions are put in place. However, I think right now, if we can get to a point where that implicit consent is more acceptable, then we'll be able to do a lot more and a lot more effectively. So that's where we're working right now, is to take away some of those barriers that are rightfully in place, but perhaps too soon.
Other questions? Okay. Okay, if not, I guess let's thank Megan again. She's come all the way from Washington,
Seattle,
Seattle. So thank you so much, Megan, for being with us and giving us such a wonderful talk.
Thank you for having me. We just hit 59 minutes.